All right, class. So good morning. Today is Monday, the 4th. The 4th. Please, if you haven't already, put your first and last name at the top of your packet for this week. It's 4/4/22. The assignments that are due this week, we have our warm-up that's due. We have our homework that's due. We have a quiz on Friday. Okay, and then we have some word problem practice that's going to be due. The word problems are on Pythagorean Theorem and distance. Okay, those are the items that will be due this week. I haven't put the essential questions up yet, but here's the essential question. Describe how to find the three side lengths of, it's really supposed to be the missing side length of a right triangle. But I will be writing that on the board. I didn't get time today. Today was busy during planning. So I'll post those tomorrow. Classwork, we're going to do the warm up first. We have a foldable that we're going to do, but we need to make sure that that I introduce a new unit. It's cluster number 7, Pythagorean Theorem in volume. We're going to do a foldable. And if you didn't, hopefully we'll do some practice problems. And while those are working on practice problems, if you haven't finished the test from Friday, I'm going to give you time at the end to finish the test. Your homework for tonight is going to be Monday in the packet. Please make sure you watch the homework help video. Don't forget about our quiz on Friday. It's going to be on Pythagorean Theorem and distance on the coordinate plane. And there are going to be some word problems on there as well. It's everything that we're going to cover this week. Anyone still writing? Okay, a couple people. Let me pause. Give you time to write. All right. Okay, let's pull out our planner, please, so we can write in our planner. Set our planner up for this week. Please don't forget, guys, please don't forget that this is a good grade. This is a easy 100 grade. This was last week, Q4 week 1. Now we're doing, this is April 4th through the 8th. And this is Q4 week 2. Okay, Q4 week 2. We're going to write the same thing over here. Please write this in. This is what I look for in the end. I don't need you to do this. It serves no purpose to do this in the end just for a grade. We have to get organized in our thinking. When you're more organized in your thinking, you tend to do well. Okay. Monday is the 4th. It's 4/4. April the 4th. Tomorrow's April the 5th. Wednesday's April the 6th. Thursday is April the 7th. Friday is April the 8th. Okay, and I'm not even going to write Saturday and Sunday because over the spring break you shouldn't have anything to do. You just need to relax. All right, so here, Math 8, homework. Okay, don't forget to watch homework help video. Okay, and tomorrow is tutoring, so let's go ahead and write that in. Math 8 tutoring, and your tutoring is online virtual tutoring at 3 p.m. The other date is Friday is our quiz, Math 8 quiz. And don't forget, the quiz is going to be on Pythagorean Theorem. I'm going to abbreviate it. distance, and word problems. And that's all of what we're doing this week. Seems like a lot, but really Pythagorean theorem is very easy to most people. So I don't think you're going to have an issue with either one of those concepts. If we don't get to the word problems, we'll do word problems when we get back. It's going to depend on how well you understand Pythagorean theorem. I won't push word problems on you until I feel like, oh, okay, you're ready. Okay, which I think you'll be ready. But if you're not, that's okay. We'll do it when we come back. And the quiz would only be on Pythagorean theorem and distance. But if I feel like we're ready for word problems, I'm going to put word problems on there. Any questions? What's wrong, guys? What y'all doing?
No,
Okay, then don't.
Okay, I'm sorry. Yeah, it's the middle of that.
Shh, later. All right, I'm going to pause. Y'all still writing? Okay, we're done. All right, go ahead and put that to the side. Let's look at the warm-up, please. All right, problem number 1. It says, in the image below, this is the image that they're referring to, the measure of angle 3 is equal to the sum of the measures of which angles? Angle 3. Okay, so this is angle 3. What other angle has the same, this outside angle? This is an exterior angle. What two angles can be added together to give you that exterior angle? This is an outside, well, let's see, equals to something. Yeah, this is an outside angle. It might help if you turn it this way and look. This is an outside angle from this triangle. Do the triangle. And there are some things that we said about exterior angles. The sum of the two opposite angles is equal to the exterior angle. So these two angles, when you add them together, and I'm covering them, this is angle, I think, what's that number there? I can't even see that number. It's 1, 2, 3, that's 4, that's 5 and 6. So this is 5 and this is 6. So these two opposite, you see how this is the angle that's directly beside it. But these two opposite interior angles, when you add them together, that gives you the exterior angle. So the measurement of angle 5 plus whatever 6 is always going to be equal to this exterior angle 3. This is the definition for exterior angles. The two opposite interior angles, the sum of those opposite interior angles is going to equal the exterior. And I need the little bitty m. The little bitty m is measurement. The measurement of angle 5 and the measurement of angle 6, when you add them together, that's going to equal the measurement of angle 3. This is the exterior angle. Please write that down. All right. Anybody still writing before I move to number 2? I'll pause. All right. So let's look at number 2. It says write an equation of the line with a slope, that's m. So m is equal to a negative 1/4 and contains the point 0, 5. Okay, so you have to figure out what m and b is. This is your m. Your b is going to be, thank you. This is your m, okay? This is your slope. Your b is going to be where x is equal to 0. So this is your b here. X is equal to 0, so your b or your y-intercept, b here, is equal to 5. So now how do I write an equation in slope? And this only works when the point, when x is equal to 0. If this was a number, you'd have to find b, okay? But since this is 0, this is where the line actually crosses the y-axis. That's your y-intercept. All right, so how do we write an equation in slope-intercept form? Y equals mx plus b. I know what m is, and I know what b is. So how do I substitute those numbers in to write the equation? Make sure you write this down, okay? How do I do that?
negative 1/4 plus b. Plus 5.
What did we forget? X.
Well,
Yeah, plus 5. You're right. Okay, good job. Any questions? All right. All right, let's take out our interactive notebook, please. All right, so this was the last page that we did, which was page 9. Please make sure you paste that down. Your glue stick is in the little, there's a glue stick that's in the little side pocket beside your desk. Please make sure that you don't abuse it, okay? Because we do need that glue. Yeah, you know, we glue things in our notebook all the time, so please just just put glue around the edges, just enough glue for it to stick, and then that's it. What was page 8? It's this page. Solving equations using square roots and cube roots. You need me to pause it here? You got it? What it looks like? Okay. All right, everybody got it? Did y'all write the title down? Anybody not have the title? Okay. So now you should have it somewhere in your notes. We did this in the last class. Now we're going to go to page 10. This is going to be intro to cluster 7. So this is Q4. This is page 10. This is intro to cluster 7. And this is on Pythagorean Theorem and volume. Pythagorean Theorem and volume. I gave you a little half sheet. So we're going to paste the half sheet down. Let me show you what the half sheet looks like. Huh? I can't do that. Well, I'll go to page 9. I just showed you page 9. Literally just showed you page 9, baby. It looks like this. Equation practice. That's okay, babe. All right, so this is page 10. What did I do? I accidentally skipped the page. Let me not do that. Put that here.
what page are we doing?
Page 10. Q4, page 10. And this is intro to cluster 7. And this, we're going to paste this down. I'm going to go this way. This is what it looks like. I had this on your desk when you came in. Let's paste that down.
All right, chill.
I don't have, wait, never mind.
Put glue around the edges. And paste that down. It's a little half sheet. And I'm going to erase. I accidentally skipped the page. I don't need to skip any pages. All right. Stuck together. Okay, so that's what page 7 looks like. Page 10 looks like. Let me pause for the comments. Page 11 is going to be Pythagorean Theorem foldable. This is the foldable that we're going to do. We're not going to paste this down until we finish writing in it. But we'll go ahead and title the page. It's Q4.
Wait, Miss Reyes?
Yes, babe.
What did page 10 say at the top?
Intro to cluster 7.
Okay. Thank you.
You're welcome. All right, so this is going to be the new page is page 11, okay? And this is going to be our Pythagorean Theorem foldable. We're learning a new concept. It's called Pythagorean Theorem. So this is going to be our Pythagorean theorem foldable. And hopefully this is very easy to you. I don't think this is a hard concept. Okay, but if you don't understand, don't feel bad about it. We'll just work through it.
What does that say?
But that is this. It's on the sheet that I gave you. It looks just like this. This is Pythagorean Theorem. Okay. We're getting ready to go to the restroom here in a minute, and then we'll start this when we come back to foldable. Okay, I'm gonna pause. All right. So this is how this foldable. This is how you fold the foldable. You need to be on this side, and you're gonna. It's a tri foldable. That means you fold it. It goes in twice here. You have 3 sections. So you see the vocabulary. Find like the middle point between these 2 sections and fold it over this way. So that when you fold this side over, probably fold it a little too far. Just enough to cover these words, I guess. And then fold this over to that line to make it a tri-foldable. So it's skinny, just like this. So when you open it, vocabulary is like the first thing you see here. And this is called Pythagorean Theorem. This is Pythagorean Theorem. Okay, and I'm going to explain. I'm going to try to be detailed without being too detailed, so you don't have, so that you can kind of understand what this means and understand the formula a little bit better. Okay. And maybe solving the problems will make more sense to you if you fully understand the meaning. All right. Does everybody have it folded? If you need help folding, raise your hand and I'll be more than happy to help you. Let me see yours, baby. Okay, so we're going to fold this over just to cover, fold this one over just to cover the words that's in the middle. And then we're going to fold this over. There we go. Anybody else need help? You got it? Did you get it, Jay? Did you get it? Did you fold it, Jay? Can you fold it, please? You're welcome. You got it? DJ, did you fold it, sweetie? You got to fold it? Okay, good. Let me see. Let me fold yours, okay? Middle part. Try to follow along, okay? So please stay with me, okay? All right, here we go. Okay, Pythagorean Theorem. There is actually a story behind this. There is a guy who has a very complicated name. So we're just gonna call him Pythagoras. That's his last name. His first name, yeah, it's crazy. So we're just gonna say Mr. Pythagoras. That's his name. He came up with a theorem. A theorem started off as a theory. That's something that somebody tries to prove, like they have an idea. And so they have this theory that something's going to work. And then when they prove it to be true in the area of mathematics, then instead of it just being a theory, it becomes a theorem. That means it's been proven to be true. Okay, so this guy came up with this idea. He started working with triangles because if you don't know, a triangle is a rigid shape, which means it's a very strong, you'll see it in structural buildings and different platforms that a lot of things for it to hold up, they use triangles to, how I want to say it, to make a building more sturdier. Okay. All right. So anyway, A triangle, by it being a rigid shape, is super important in the world, in some people's world that are in construction or that are in architect or whatever. It's super important that they know about these things. So, with a triangle, he came up with this theorem, which is a formula: a squared plus b squared equals c squared. And there's a method for his madness. The a is a number, the b is a number, and the c is a number. And it's actually lengths of a right triangle, and only a right triangle. What makes a triangle? Does anybody remember? What makes this a right triangle? Because of this 90-degree angle right here. That's what makes it a right triangle. Okay. So in this, I'm going to label this picture as a right triangle, because Pythagorean theorem is only used with right triangles. You can't use it with any other type of triangle, only with a right triangle. So I'm going to even put a star, because you can only use Pythagorean theorem with a right triangle. So far, I'm going to repeat what I just said so that maybe it'll stick. This is the Pythagorean theorem. It's a formula that you can only use with a right triangle. This formula is called the Pythagorean theorem. You can only use this formula with a right triangle. Is everybody okay so far? Yeah. Okay. And who came up with this theorem? What was his name? Pythagoras. Yes. Okay. And that's why he called the theorem. Of course, if you make something, you're going to name it after yourself, right? I mean, most people do that. So, and that's what he did. All right. So with this triangle, he labels the legs, or these side lengths, as A and B. So this is my side A. This is the measurement here. This is A. This measurement he labels as B. And the slanted side, the side that's opposite of the right angle, he labels that side C. Okay? So you have your A, your B, and your C. All right. So this is length A, this is length B, and this is length C. Your A and your B lengths, and I probably should write it down here, but your A and your B lengths are called legs. This is a leg, and this is called a leg. These are your legs. So it's okay to label this B and this A, or this A and this B, because they're both considered as legs. However, the side that's opposite of the right angle is actually the side that is the longest out of the three. So it's the longest side, and it's opposite of the right angle. It has a special name. It's called the hypotenuse. 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 That's weird, but I've heard stranger. It's called the hypotenuse. Ladasha with L-A and then a dash. That's somebody's name. That's strange to me. Or a symbol as a name. I'd be mad if my mama did that. Ooh. I'll just be like, really? What was you thinking? Like, that is not going to be my name. I'm going to make up another one when I got old enough. Can you imagine just being a symbol? Oh, no. You got to do better than that. Would you? I mean, come on. Would you want to be just the symbol? I mean, how do you say that?
Would be cool.
No, cool my foot. I don't want to be cool. I want a name. Give me a name. No, that is crazy. And what's people supposed to call you? Symbol? That is ugly. Well, no, I want a name.
You have a last name, right?
I got a last name, but I'll be mad if my mama name. That's just me. I want a name. I don't want to be no symbol. But people do stranger things, so I'm not judging. I'm just saying for me, absolutely not. Because some people think that my names that I would want to name my kids, some people think they're ghetto names. And I'm like, I don't care. I want my ghetto name. It is what it is, right? All right. So let's look at this. This is the breakdown of how he came up with this theorem. Okay, I'm going to pause, ladies, so y'all can understand. I don't want you to miss nothing, because when you miss it, you're going to be like, Miss Reyes, I don't get it, because you wasn't listening. Y'all ready? All right. Okay, so look, this is a triangle. This is a right triangle. Again, this side is A, this side is B, and this slanted side is C. Now, this is what he learned. This is how he came up with this formula. He learned that this length right here, when you square it, this length right here is 1, 2, 3 units. But when you square 3 units, a squared, when you square it, and you square this length is 1, 2, 3, 4. So this length squared, 3 times 3 is what? 9. You see how it's 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's this part. He squared this length. The length is 3, and he took and squared it. 3 to the second power is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. He did the same thing here. This length is 1, 2, 3, 4. He squared 4. How many squares are here when he squared 4? Count them. 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So he squared B right here. B squared. This is 4. 4 squared is 16. And he found out when you add these two squares together, it gives you the total this square. So let's add them. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So let's count this one. This length is 1, 2, 3, 4, 5. What's 5 squared? What's 5 squared? What's 5 times 5? 25. You got to know that 5 squared is the same as saying 5 times 5. So let's count to see if that's 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. When you add these two squares together, the a squared and the b squared, you equal this last square here. So 9 plus 16 is equal to 25. That's what he found to always be true about a right triangle. So since he know that to be true, that anytime you have a right triangle and one of the sides is missing, you can find the other side by using the Pythagorean theorem. And that's what we're going to do. Any questions? So this is, I'm going to write this down for you. This side is 3 squared, which is equal to 9. This is 4 squared, which is equal to 16. And this length is 5 squared, which is equal to 25. And that's true. 3 squared plus 4 squared is equal to 5 squared. This is 9 plus 16 is equal to 25. Excuse me. Raise your hand if you're still writing. Okay, let me pause. All right, here we go. You have to. You need those memories, though. All right, so what did we say a right angle was? Definition. It's a 90-degree angle. Exactly 90 degrees. That's exactly 90 degrees. A right triangle has one 90-degree angle. So I'm going to put here because that's important to know too. Right triangle has one 90-degree angle. Okay. All right, legs. Your legs, listen, the legs are going to be your A and your B. It's the sides that form the right angle. The sides that form the right angle. It's those sides that form the right angle. This is the right angle here of a triangle. It's these two sides right here. These two sides are legs. That's your A and your B. This is your A, this is your B. Your A and your B are the legs. It's the sides that form the right angle. This side and this side. Those are called your legs. All right, hypotenuse. This is the side of the triangle. This is the longest side of the triangle. longest side, and remember, we're only dealing with right triangles. The longest side of the right triangle. It's also the slanted side. Okay. So of the right triangle, this is the right triangle. Oh, and the side opposite of the right angle. Opposite the right angle. Who is chewing that gum like that? Good Lord. Okay, so this is opposite of the right angle. This is your hypotenuse. That's the hypotenuse. You don't even have to tell me. You know I know. All right, look. Square root. This is the square root symbol. Remember, that means what one number can be multiplied times itself to give you the number that's under the radical. What number can be, sure, can be multiplied times itself to give you the number under the radical. All right, that's what it means. So like the square root of 25 is 5. Why? Because 5 can be multiplied times itself. 5 times 5 gives you 25. So the answer is 5. And we are going to need to know that to solve these problems. All right, let's do this example. Okay, so remember, this is we're checking to see if it's a right triangle. We don't know yet until we substitute these numbers into the formula to see if both sides are true. We're going to assume that this might be a right triangle. Okay. If this were, this would be my A, this would be my B, and this would be my C. These are my legs, and this is my hypotenuse. So now I'm going to see if this is a right triangle by using the Pythagorean Theorem. A squared plus B squared equals C squared. Okay. We're going to substitute. The value for A is 5. You see right here, this length is 5. So we're going to put 5 here. So this is 5 squared. Plus the length or the value for B is 12. So we're going to put 12 squared. And then it says the value for C, this long side, the side opposite of the right angle, which is called the hypotenuse, is 13. So we're going to put 13 squared. So we're going to see if this is true. If it's true, then this is a right triangle. If it's not true, both sides are not equal, then it's not a right triangle. All right, so let's prove this. We got 5 squared. What's 5 squared equal to? We just did it not too long ago. 25. 5 times 5 is 25. What's 12 squared? 144. Good. And then does anybody remember what 13 squared is? 100. It is 169. Okay. So now let's add these together and see what we get. Let's do 25 plus 144. What's 25 plus 144? 169. Okay. So is 169 equal to 169?
Yes.
Yes, of course it is. So this is a right triangle. If it didn't work, then it's still a triangle, but it's not a right triangle. Okay, you got this written, babe? You got it written? Huh? Mm-hmm. Come on. All right, here we go.
So
This is A.
I can scare you. I'm just not trying to.
See, there you go. Yeah, seriously. That's what I'm saying.
If I want
See,
to scare you,
okay, let me
scare
pause this. Jesus.
I'm not crying.
I might just tape just